Hi, I'm just showing you some pictures of the mini lathe construction at the moment. It's been a while since I've done it. This is the gearbox. So yeah, here I'm looking at the way that the original belt doesn't fit the new pulleys very well. Obviously it's a different belt, and well, the belt doesn't fit the original pulleys very well either, does it really? It's a bit of a joke. I'm surprised these last as long as they do with belts that fit that well, but that's apparently the fit on these belts. There's a lot of gaps. And then just a quick shot looking down. Oh, there's the headstock on top of me, headstock of my whole block, showing the difference in size. Quite amusing that was. And here I am making the lock nuts for the spindle. I see them in the Stevenson's collet block. There they are in the little mini mill. That works beautifully now. It's got a 3-phase motor on top of it, and it's cutting that at full depth. How's about that, eh? It's obviously a slow feed rate, but it goes straight through at full depth. No chatter. You'll see the finish in a bit. Quite impressed with that. And then here's the shaft. Got a bit of deflection on my first keyway with this. I went full depth. You may see some of the pattern in the keyways on a closer shot, and there's a bit of a divot in one side of it, unfortunately, and I learnt my mistake. I think this side turned out parallel and all good. At the other side, yeah, that side looks pretty good. It's a bit of a blurry picture, but that's okay. And then the other side's got a bit of a tick at the front there as the mill went in and started wandering to one side. And I adjusted my method and got it good. Doesn't look too good in that picture because it hasn't had no finishing done to it yet. It's still just swarf everywhere. And obviously I put the nuts back into the lathe. These are just mild steel, and parted them off. And after parting them off, I didn't like the look of the silver, so I decided I was going to heat treat them here. I'm heat treating them over a pool of oil there, just heating them up until they turn blue, and then dropping them in the oil, and doing it again and again and again until they are black. And you can see there they're looking quite black, so I'm quite happy with that colour. And there they are finished on the shaft, which has been polished up there. You can see the little defect on the left hand side. The nuts looking very nice straight cuts through at full depth they were. I don't know what the problem was on the original, I can't remember, it's that long since I did it. Here's the spindle housing, or the dubbing motor as I'm calling it. And it's been machined on a mandrel which I made for it. There we go. So what I'm trying to deduce is how fast the original motor turns, and that determines how big a gears I need, or if I can just do a direct replacement. So this is the original motor. I haven't got a clue what RPM it goes at, but I do know the lathe is rated at 2,500 RPM, so 2,500. So you're thinking, the motor must do 2,500. Wrong. The other gears involved in this are the two plastic timing belt gears. So the lathe has a timing belt. This is the timing belt gear off of the motor. So that's what the motor drives the lathe with, and that's the driven gear. Okay, so that's a 17 to 31. Those who are good at mathematics have worked that out already, but I'm approximating that is around about a 45% reduction. That's around about a 98%, a 2% reduction. This is a 45% reduction, So that's about 47% reduction. Which means that motor must go around about 5,000 RPM. That's at full chat. So I'm working on the premise that that works at 5,000. So if I keep this 17 tooth gear and put it onto my new motor shaft, the motor shaft will be in here by the way. And I want that to spin at 5,000 RPM from a 2,850 RPM motor, then I'm going to have to do another gear increase on the motor. So I'm going to have a 1.5 horsepower motor and I want to increase its speed by 33% approximately, reducing its power from 1.5 horsepower down to 1.2 horsepower, something like that. No, 1 horsepower. So I'll end up with a 1 horsepower lathe if I get a 1.5 horsepower motor, which is what I'm planning on getting, and still achieve 2,500 RPM at 50 Hz. Obviously with a VFD you can overclock that to 60 and 70 Hz. You start losing a bit of torque at those high speeds. So theoretically I could achieve 3,000, maybe 3,500 RPM, which is what the Holbrook C8 does. So I'm quite happy that a 2-pole 3-phase motor is going to do this. Pretty happy indeed. So this is the possible setup for the mini lathe counter drive shaft. This will have 2 slots cut into it corresponding to the 2 slots of the lathe body. Then this will be able to slide up and down, so it's going to be a close fit. And I've got some 10mm shaft here. This is for a triple pulley, which I will have to machine each pulley individually to fit inside each other. You'll see it when it's done. And then this is the size of an individual pulley on its own. Just simply put on, grub screw in, keyway in it, blah blah blah. As you can see, there isn't a keyway in this shaft yet. That's all that's left to do on this shaft, just put keyways in it. One the full length there and one the full length of that journal. So that's 10mm journal, 7/16 by 28 unified extra fine thread. I was going to do 11 by 0.75 or something, but I wanted to use the threading dial on the Holbrook here, so I just did an imperial thread on it, and the threads had to fit in between a 12mm journal and a 10mm shaft. So 7/16 just did that. Okay, I've looked at wiring diagrams, I've tried to find information, but my motherboard inside the control box has one wire, one connection on one motherboard, different to every other wiring diagram that I can find. It shouldn't make any difference. So I've got it wired up. The motor's plugged in. The only thing that we haven't got is speed control, because the speed control ain't on. I haven't plugged it in yet. I'm going to plug it in now. So it might blow up straight away, because I don't know, but the switch is in the off position, so it should be alright. Let's see if the plug reaches. So it hasn't blown up straight away, and I'm not getting electrocuted, and we have power. The red light has come on. I don't know if you can see that. Let's zoom you in, let's see if you can see that. So I'll switch it back off again. Red light goes off. See the red light down here. I'll put it back on again. That's a good start. It's a good sign. So I'm now going to turn the potentiometer on and see if we get any sparks. No sparks. So we'll turn this might create sparks. The digital display's on at the top as well, that's good. Let's put the lathe into forwards. No, it's blown. Yeah. And it's blown all the fuses in the house as well. Something's exploded. So that was a bit of a waste of time and effort. Oh, great. Oh yeah. The fuse blew. Well, that's good. So it's handy when the fuse blows. So we might be able to rectify it, because that's what happened in the first place. I mean, when I say the fuse blew, it shattered. I can't get the cap out of there, and I've just got a rubble of glass. That was a 5 amp fuse and it obliterated it. Stupid. So stupid. Okay, be careful. On. No tack. The tachometer is not working. No tachometer. Turn the tack off. Turn the switch on. Bang. Bang. So I'd say the MOSFETs are probably blown on it. Do I really want to go through the MOSFETs? Let's make it safe first before I start contemplating shite. Oh dear. Let's turn it all back on again. It's been repaired. That's been repaired, and here's what's happened to this. So there we go. So got it there. All repairable. I don't know what's blown off of it, I can't remember what was on it. I think it just took a track out from a diode. It is a diode. It's definitely a short circuit. I should have popped something off the board. Might have done. Anyhow, that's scrap. Okay, so considering the condition the lathe came in, it's swapped around, and that fuse that was exploded inside it, I'm guessing that was a problem all along. Now I gave it a decent blast, as good as anybody would, but I was planning on upgrading the motor anyway on this. I just wanted the DC motor to work straight away, but it obviously isn't going to happen. Okay, so you can see the old motor here, that's still good, that's absolutely fine, not a problem with that. And I've dug out this, which I've had for about 2 years. It's a AC to DC converter with a speed controller in it. So I can use that for some other project, it's not a problem. And for this, the mini lathe, the inverter has showed up. So I've got a VFD in there, that should be puck up. Don't know what size it is, that's probably going to be double the size that I require. So 1.5 kilowatt inverter. So it says on there it's a 1.5 kilowatt inverter. So that's all good, that's all ready to go. Then I've got the motor. This is going to be the motor for the mini lathe. And it's a 0.75 kilowatt motor, half the size of the inverter. Brand new, keyed, so just a standard motor, standard stub axle, standard B3 mounting, whatever you call it. I didn't get the flange mount one, more expensive, not a point, it's dual voltage, it's all good. So that will be around about 1.5 horsepower. And also the gears came in, the pulley wheels. There's a load there that I haven't done anything with yet. And here I have started assembling the compound pulleys, which will be those 3 sizes there. There'll be identical pulleys, but clearly the opposite way round, which will be going on the motor. So there'll be a 2-to-1, a 1-to-1 and a 1-to-2 ratio there, nearly finished. What else we got? Oh yeah, the dummy motor. I didn't put slots in it, I just put 2 carriage bolts. They have squares on them, you press them into a hole which is too small for the square, and then they're in there pretty tight, so they're in there. Obviously I've painted it with an anti-rust zinc paint, which is a lovely colour of green. There's the 2 HK or NK nuts, whatever they're called, locked together, and because I made them they are concentric, so a gear can butt up against them. I've made them so they are flat at the edge, so a gear can just go straight up and butt up against it and rely on it being square. And because they were homemade and they weren't made to any specifications, I just made for a pleasing thing, I made a couple of spanner tools. So they've got a piece of hardened steel as the tooth there, and the rest of it is mild steel, and it's all screwed together and glued together. I spent a bit of time making those. I think I bent this one. Yeah, I bent this one at the end here. This one's bent. Not to worry, I bent it in the lathe trying to mess about. Enough said, it's done. And again, a hardened piece of steel in the end there. And that allows me to link on and link on and then undo. And drop the nut. Why not? Sounds like a good idea. And obviously that's too tight now for me to undo. I can't undo that tightness now without grabbing that end, which I'll have to put into a soft jaw. I'll give it one more go to try and show you the assembly. Give me a second. So with much struggling I managed to get the knot off. Okay, I'll just spanner back down to somewhere where I'll find it. I'm going to do that with the other one. So the nut comes off. Then the shaft comes out, and put the nut down here. And the shaft comes out. and that is trapped in there. You cannot get that out. And there's no side to side wobble in that at all. That is perfectly, it's perfectly in there. It just slips around nicely. So assembly, make sure I get it in the right way again. It's a bit hard to disassemble because when this thing is out of alignment, it doesn't like moving side to side when it's out of alignment. So that goes through there. The spacer in the centre, which is holding the inner races at the right spacing apart. The outer races are a press fit, 1 or 2 thou press fit, I can't remember what it was. It was pretty tight but not too tight. Any of the 2 lock nuts can go on. You want them pretty tight. That needs to be locked up. So a bit of tension on there. And now I can turn it from the centre of the shaft, and that is, I was only holding on to a 10mm shaft and tightening it, so that's tight enough to, it's just nipped so it's nice and tight there. The second nut goes on, it says confidently. Second nut goes on. Of course, in doing that, the first nuts come loose. Always the case. That spanner goes on back to front, and the second spanner goes on. And it's all come loose, doesn't matter. I'll do it properly again another day. When that comes off, it's loose in there now. Although it still turns it just about, not quite. Just needs nipping. And that is going to be the dummy motor. Simple as that. And that slips into the 2 slots which are already there. And now that can move up and down to provide tension on the cam belt, which runs to the headstock. Now to tension the motor, that is another thing. That's to do with the plate which I'm going to make for the bottom of the lathe. And the reason I'm making a plate for the bottom of the lathe is, if I make a plate which comes off of the dummy motor and attach that big 3-phase motor to it, then there'll be a lot of flex here, and that will flex the lathe. Could put twist in it, could do many things. So plan of action to prevent that is, I've got a piece of 10mm thick steel, long enough to reach from the back of the lathe all the way through the building. 3 meters long, so I'm going to lob off a piece which is from the back of the casting, from the foot to the front foot casting, the end of that. So basically it will accomplish both feet fully. Then I'm going to scrape in the feet on the lathe flat and parallel to each other. Then that steel plate, I will scrape that steel plate in flat and parallel on both sides and bolt the 2 together. And then there will be a plate coming off of that, coming up at an angle, and then a flat section for the motor to go on with a motor plate, which will probably fold backwards, fold it hinge on the back, and the motor will fold away from the dummy motor for tension. So you'll be able to push the motor down, swap your belt off, and then it will spring back into position, something like that, some kind of arrangement. That's what's happening there. So that's it for this video. That is basically complete. You get the gist of that. And all the operations that I did making this dummy motor can be made on the mini lathe itself with just a 3-jaw chuck before it breaks. So I highly recommend, before the motor control breaks on your mini lathe, get proactive and at least make that dummy motor ready for the new stuff to come along, because putting the 3-phase on in comparison to messing about with this, well, this was going to cost in the region of £130, £140 to repair properly. Not a lot of money. The gears cost £30. The motors cost £95, and the controller I think was £50. So that's £180. But the motor will probably last for an infinite amount of time. You know, it's an induction motor. They're pretty bulletproof. I should imagine if you're a hobby user and don't use it that often, you will never have to do any maintenance to that motor whatsoever, as long as it's covered from chips. The inverter, however, if you bought a 0.75 kilowatt inverter, I should imagine it would last 2 or 3 years. Because I've bought a 1.5 kilowatt inverter, I should get between 5 and 10 years out of that, I should imagine, if not more. And I've used heavy duty sealed rolling bearings in here. So they were double row 62 series, weren't they? That's it. 62, 10, 2. So the double row bearings. That was what I did. That's what I got. So instead of just 2 roller bearings, it's like having 4 roller bearings there. That's what I went for on that particular one. 63 or something else. So they should last a long time. The aluminium pulleys shouldn't wear out, so they'll last forever. I've upgraded the gears in the headstock to steel gears, so they shouldn't rip themselves to pieces. And I've gone up from an unknown, can't get anywhere else apart from Amadale website cam mount, and I've upgraded to a T5 cam mount. So you know, it will all be T5. It will be T5 from the motor to the dummy motor, and from the dummy motor to the headstock. So it's all readily available stuff for only around about £50 more, I should imagine. But a hell of a lot more work, obviously, a hell of a lot more work. So it's highly recommended that you do that. Now, next project is going to be the lead screw. I think I'm going to attack the lead screw and the worn out lead screw bearing block. So I'll be cutting the end of the lead screw off and modifying that. But for this video, I think you get the gist of what's going on. It's going to have a 3-phase motor fitted to it, and it's going to be a lot more reliable. It's also, in this arrangement, going to be self-contained. You're going to be able to pick the lathe up, and the motor's going to come with it, and you're going to be able to plug it somewhere else, because this is just basically a benchtop lathe, and sometimes you want to get it out of the way, don't you? Or if it's a very rarely used equipment, you want to oil it up, grease it, and put it away in the cupboard, and then take it back out again. And that's how these little compact lathes can be used. Well, the new motor will come out about here. It will make it slightly wider than normal. But beyond that, I'm going to be bringing out the chip shield this far, which makes the lathe a lot more usable, because the original chip shield lends itself to getting wrap-ups around the chuck and dangerous situations from fillailing metal really easy. Whereas if you give yourself a bit more space out of here, I've seen a few people do it, but I will quote Aide's Workshop. He's a lad in Wales. He's got a little Walco lathe that's slightly bigger than this one, and he's extended his splash shield out. As for Steve Jordan, he's a little mini lathe enthusiast. He's made his splash shield quick release by putting long studs in. There's many ways of doing it. I'm going to make mine longer outwards, wider outwards, and then the same length out here. But you know what I mean? It's just going to be a bigger box to contain more chips. Plus protects the motor, which will be out here somewhere. So that'll be happening. And as for the cross slide and compound and traverse, I want power feed, and I'm going through many orientations of how I'm going to do power feed for the saddle and apron assembly. I think I've got it in my mind. I'm not going to let too much out on that yet, but this is going to be power feed in the mind of being able to easily upgrade it from the power feed to a semi or full CNC kind of setup with the lead screw and everything all combined into a single system. And hopefully that single system will incorporate the ability to have a type of scale. Instead of putting scales on this system, I want the movements of the hand dials to be directly linked to the movement of the slides and be able to be recorded and displayed on a screen. I don't want to put slides on for that. I want that to be incorporated, so it's probably going to incorporate some kind of servo motors with feedback to be able to do all that in a very compact way. And I'm looking at it for an inexpensive way as well, and a compact, inexpensive, compact and powerful enough to, you know, take the kind of cuts that this lathe can do, which isn't considerable, but it's a lot more capable than a watchmaker's lathe, and the size of it makes it able to compete with a watchmaker's lathe for delicate little items. So you know, it's a very versatile little lathe. This is very versatile. I like it. The more I look at it, the more I like it. Really, it's a very nice little lathe. It's just limited by length and diameter of what it can work on, which is not a problem. It can do small little piddly parts like that. So when I want to make a little M4 screw, this is the lathe I will turn to. Anyway, that's enough of this video. I'll be back. I think I'm doing the lead screw on it next. I'll be repairing the lead screw. So I'll see you in that one.